Turner Construction is currently in the construction phase of the Golden One Center located in Sacramento, California. The project, $507 million total, is not only including an indoor arena, but also a multi-use development adjacent to the arena. The completion date for the entire project is set for October 2016, in time for the NBA season. The project is funded by the Sacramento Kings.
Lendlease was hired by Turner to observe the construction at the Golden One Center in Sacramento, California, and find possible ways to improve their construction process. We plan on looking into site conditions on the project and also include an analysis of existing operations and problems, proposed improvements, and an implementation plan with costs for the changes. We plan to do this using crew balance charts, process charts, and flow diagrams. From there, we will be able to show the project managers at Turner potential ways to improve the productivity on the job. One improvement would include the work done on the erection of aluminum framework for the forms and concrete pouring. We believe we found a way to improve the process which would increase the productivity and most likely decrease project costs as well. The second improvement didn't change the crew composition but focused on the process of erecting the aluminum framework. The third improvement we found for the project was a suggested change to the crew composition of the decking formwork crew.
We reviewed some of the construction processes at the Golden One Center job site in Sacramento, California. The Golden One Center will be a 1.5 million square foot venue and is designed to hold 17,500 people. It is also LEED certified and is being called the world's most connected indoor sports and entertainment venues. The two processes that we focused on during our review were laying decking and setting up aluminum framework. The decking was done in two phases, with one laborer working on the more open spaces of the floor, while two other laborers worked to fit the decking around the columns of the building. While monitoring this process, we came up with one improvement to help increase productivity, which we will further explain in the later slides. The aluminum framework was completed by having two laborers transport the aluminum framework over to another laborer who was on a scissor lift. The aluminum framework was then raised into place, secured and inspected, and then the two laborers would go and get the next piece of aluminum framework. While monitoring this process, we came up with two improvements to help increase productivity, which will be explained in detail in the later slides.
Within the footprint of the stadium, the job site is very cluttered with materials and tower cranes. There's not much empty space within the job site due to the large amount of materials needed for the construction, which makes moving materials throughout the site more difficult and slower. However, the site is very organized in that similar materials are grouped together and are stacked to take up the least amount of space. The similar materials are not stacked excessively high to limit the danger of them falling over. There are fences set up to divide the job site into different sections, and this is most likely to keep materials separated and organized. Unlike the footprint of the stadium, the ground around the stadium is very clear and open. In this area, they are using lifts, so they need the free space to be able to move the lifts to their desired locations. During our observation, machines were moved safely when needed, and all observed laborers were wearing the proper PPE.
We utilized three methods of study to analyze the Golden One Center. The first is a crew balance chart. This method tracks a construction crew's actions minute by minute to analyze their productivity and efficiency. The actions of each member of the crew is tracked in bar graphs, which are plotted side by side. This lays out the process for the entire crew and allows us to choose the most efficient combination of workers for a particular process. The next method utilized for this project was flow diagrams. These are line sketches that show the movement of people or things throughout a construction process. This provides a visual aid of the construction process and allows us to see if any of the activities overlap with one another. The final method that we utilized was process charts. A process chart chronologically lists the steps of a construction process with the aid of 5 symbols that each represent a different process.
One of the activities we analyzed was the erection of aluminum framework for an elevated concrete slab. There were 3 laborers on this process. 2 were on foot and 1 was operating a scissor lift. First, the 2 on foot would locate and transport the aluminum framework posts over to the site where it was to be put up. Then one of the laborers on the scissor lift would take one of the ends of the poles and it would be lifted up into position. Once it was raised into position and secured, the scissor lift would be cleared and two laborers would inspect the post that just went up. Some potential problems we noticed with this is there was always one laborer sitting idle. During the moving of the post over to the position, the laborer in the scissor lift was idle. During the raising of the actual posts, one of the laborers on foot was sitting idle, and then during the inspection there was one sitting idle.
Crew improvements. One of our proposed improvements is to add another laborer to the aluminum framework process. This idea came from watching the process and noticing that there was one laborer who was idle after transporting the framework over to the scissor lift from the laydown area as another framework piece was being put into place. So adding this other laborer will allow two laborers to carry the framework over to the scissor lift as the previous piece of framework is being installed. That way, as soon as the scissor lift returns from the top level down to the base level, it is able to move that framework up to the top again, therefore reducing idle time. Another improvement we came up with is to have the scissor lift operator inspect installed framework. This reduces the idle time of that operator of sitting waiting for the next piece of framework being delivered to the base of the scissor lift. So while he's waiting for the framework to come from the laydown area, instead of just sitting at the base, he's now inspecting the previously installed piece of framework. This allows for this process to move much faster.
The first improvement for the aluminum framework process is adding an additional laborer. By adding the laborer, the flowchart becomes two different cycles, one with the laborers transporting the aluminum framework, and the other is the laborers placing the aluminum framework. These can now be done at the same time instead of one after another because of the added laborer. The daily cost of adding an additional laborer is $303.20, and this number is taken from the RS Means Handbook. The next improvement is to inspect the framework while the lift is being lowered. This changes the flowchart by having two tasks being completed at the same time. This will allow the next piece of aluminum framework to be put into place as soon as the lift is lowered. There is no additional cost for this improvement. It only changes what tasks are done when and does not require any extra workers or equipment.
We observed the decking operations for the elevated slab formwork. To accomplish this, the contractor is using a 6-man crew, with 5 of them being carpenters and 1 foreman. The foreman was there for oversight and quality control inspections. Carpenters 1 and 2 were measuring, cutting, and installing partial sheets of decking around the points where the columns protruded from the elevated slab. Similarly, carpenters 4 and 5 were accomplishing the same activities for the boundary of the slab. Carpenter 3 was the only individual laying full 4x8 sheets in the open area between each boundary. This was by far the most productive member of the crew per square footage of sheeting laid. Additionally, the carpenter foreman was spending most of his time commuting between quality control sites. This was a severe waste of time.
When analyzing the concrete form decking operations, we found 2 problems, as highlighted earlier. Problem 1 came from the fact that the foreman had to travel between joints that he was checking. Checking the joints is necessary for quality control of the project. However, better planning of the checking schedule could be accomplished. Having another foreman could reduce the time. However, due to the expense of a foreman, this is not advised. For the second problem, we noticed that Carpenter 3 was the only one handling full sheets. This activity can be better optimized by adding a laborer to assist in the transportation of the large sheets.
The implementation of an additional laborer into the decking formwork crew increased the productivity of the crew significantly. The updated crew balance chart shows that the additional laborer was able to work hand in hand with Carpenter 3 because the laborer can perform the sheet acquiring, transportation, and placement. The duo is able to work with full sheets much more efficiently than when the carpenter was trying to handle full sheets by himself. The improved productivity was 380.95 square feet per man hour, and the improved labor unit cost was $0.68 per square feet. This was an increase of 114.28 square feet per man hour over the original crew balance and a decrease of $0.42 per square feet from the existing crew balance. Further improvement could be possible by providing a laborer to help each carpenter. Overcrowding would not be an issue on this site because of the amount of open space. However, because the laborer cannot complete the measuring and cutting tasks, the additional laborers would not provide as much improvement as the first additional laborer.
Overall, the Golden One Center is an extensive project, and we believe that Turner is doing an adequate job keeping their workers productive and the job site safe. If Turner was to implement our suggested changes to the erection of the aluminum formwork, the concrete pouring, and the decking formwork, we believe that they would be able to save time and money on the project. The crew balance charts, process charts, and flow diagrams show how the changes would affect the current way the job is ran and the proposed improvements. Utilization of construction productivity measures before, during, and after a project can help to determine areas for cost savings and schedule improvements. Although productivity consulting can at times seem unnecessary, the possible savings can be quite large. Improvements based on sound analysis and unbiased observations can impact the overall cost of a project significantly. It is for this reason that we highly recommend continual correspondence from Turner for this and any future projects.